you the presentation of this session? You are presented? No. Do you are present? No. Okay, we are only two.
Allora, aspettiamo, possiamo partire. So, good afternoon. Are you presented in this session? No, okay. So, good afternoon and welcome to the second session of the workshop City Territorial and Planning. I'm sorry, but I am the chair of this session because the Professor Beniamino Morgante is busy in the other session, and I am. And we have today 4 presentations, but I think there are only 2 presentations, one in virtual and another in presence. The first one is Gustavo Vargas de Andrade with the presentation towards an augmented reality application to support civil defense in visualizing the susceptibility of flooding risk in Brazilian urban area. So, Gustavo, the floor is yours.
Thanks. Hello, everyone. My name is Gustavo Vargas de Andrade, and I'm an undergraduate student of software engineering from Santa Catarina State University in Brazil, called UDESC. Now, I'm going to present the research towards an augmented reality application to support civil defense in visualizing the susceptibility of flooding risk in Brazilian urban areas. First, we are going to talk about the flooding problem in a general context. Floods are the most frequent type of natural disaster and occur when an overflow of water submerges land that is usually dry. Floods are often caused by heavy rainfalls. For example, that happens when the rain volume is more than the soil can absorb. Urban areas are a major affected by this event, as the non-well thought out occupations are made, decreasing the rain runoff. One example of these events may be seen in this picture of the São Bento do Sul flood disaster in 2021. Problematic. The picture shown in this slide represents the natural resilience that the Brazilians used to have. It is one of the actions to mitigate floods here in Brazil, where the floor elevation is made in order to create a barrier for the water in the street level. This is engineered without any technological support, which represents efficiency and adaptation. In fact, is done just for their crucial needs with lots of creativity. In a general context, this is made without any relation with public policies or any kind of intervention to mitigate the problem for local administration. On the graph figure, the importance of developing the neocartography application is concretely justified, since the repeatability of the occurrence of the flood phenomenon recorded by the official state agency, Civil Defense, associated with the harmful effect of the event, flood, that was reported between the years of 2013 and 2021. The harmful effects of floods on the state's economy is significant, and without a doubt, much more noticed in people's lives.
Sorry, Gustavo. Sorry for interrupting you. Can you try to talking more strong, because we hear your voice very, very slowly. Can you try, please?
Okay, I will try. Do you want me to repeat?
No, it's okay for now.
Okay.
If you try to talk with voice more strong.
Okay, that's no problem. Here I expose some of the points that made us choose an AR application. Innovative. We choose to create an augmented reality app for the research subject because it's a technology in Brazil that's becoming a major game changer. Thus, it is clear that the app Neocartografia will have a remarkable impact for all civil defense environment here in Brazil, ones that right now they do not have similar application. Relatable. AR is far more relatable than just explaining what is going to happen when it rains. The whole purpose of for us to be using an AR application relies on the reliability of the simulation in the public's mind. Therefore, the water depth, size, and speed received special attention to be one step ahead on the feeling of reality that the simulation provides. Presentable. To be validated as a tool for civil defense, the application Neocartografia was made to have an easy and intuitive relation with the user. Then, the app simulation and the technical parameters definitions are designed to be an interactive experience that can be handled by the most part of the people. For the app development purpose, we have been using the Unity game engine that allows to implement the AR Foundation library, which is provided for public use by Unity Technologies. AR Foundation is a package that allows to building cross-platform AR applications in Unity, both iOS and Android development. In fact, for the application, we have to customize the plane detection plus point cloud feature from AR Foundation in order to develop the necrotography simulation. The algorithm process can be followed by the figures, which I'm going to give a brief explanation. First, we start in the simulation main screen. Then, the plane detection starts. Points are placed wherever a physical barrier is detected in the real world. The lowest point on y-axis is chosen as anchor. The plane on x-axis is placed based on anchor and water depth. If is there a new anchor point, the lowest point of this point cloud is chosen as anchor. And again, the plane is placed in the x-axis. Historic flood events. Another feature that was implemented in cartography is the historic flood events. Once there is possibility to reach them by public access by the system in the ENA, National Water Agency database. In order to give an opportunity to investigate data from historic flood events, neocartography allows to simulate flood events. For instance, to consider 10 years ago with an intense flood event for different scenarios of flooding. This feature in the app enables civil defense agents, as well as the other users, to get historical information of flooding about areas that are right now susceptible to a similar event. The figure demonstrates on the left image, A, how the historic data is consulted in the app for support the civil defense agents to get the historical data of local occurrences. Later, this information will be used in order to set up the data on the simulation as well as to visualize the query results. For example, the flooding depth on the smartphone screen. Knowing the history of the local occurrences. In the smartphone search screen application, the user fills out the station ID and the time range. The right figure, the B, shows the search result. There is a combo box component with the series of measurements identified by the date and the time. The users must select an item from the combo box and also click on it. Just after that, it will be revealed how was the fluid situation on that specific date and time. AR limitations. In this topic, we are going to discuss about the AR limitations faced through this application development. Hardware. Hardware limitations restricted some cases. Besides not being able to use iOS devices with LiDAR technology, we not noticed that in a wide outdoor environment, the camera in our smartphones, a Samsung Galaxy Note 9 and a S9 and a Galaxy Note S9, could not correctly identify distant planes, thus not drawing the water plane in places not close to the device's camera. Distant planes. AR could only identify planes relatively close to the user. And based on our tests, and with the limitations in mind, we came up with a formula of how to improve floor identification. The left figure, A, represents the main formula, where the effective view and the effective simulation distance lay on the angle of A and the total height of Y, simplified by the function below it, as you can see. Considering the right figure, example B, it shows a simple scheme whereby the formula, the effective view, and the effective simulation distance lean based on the function below it. Here are conclusions and thoughts for future work. iOS version with LiDAR. For future work, we acknowledge the benefits of iOS's LiDAR, and as in recent tests, we confirmed that iOS LiDAR with LiDAR is much more robust and precise than normal smartphone cameras. Location-based historical event search. The search for historical data is made manually right now. We aim to make it by an automatic query based on user's location, searching the nearest watershed. Cartography proved to be a potential tool to risk management, easy to use and easy to understand. Our first trials showed that the application has an intuitive interface, but still needs to be improved. It is a low-cost solution. The most people on civil defense has a smartphone, so it is a more cost-effective solution than a specific virtual reality gadget, for example. Test suites in partnership with civil defense and their expectation for public use. We want to acknowledge the help from our partners, FAPESC, ENA, National Water Engines, Civil Defense, CNPq, and CAPES.
Okay, Gustavo, thanks for your presentation. I ask you if you have any question for this presentation. No? Gustavo, just curiosity. How your research can contribute in planning in specific?
In planning,
Yes, in urban planning.
just a minute.
For example, with instruments or with a specific plan, I don't know. You talk about the flooding risk, and I think this is important for urban planning. Yes.
It's an application to mitigate and to help people to understand the risk of flooding. So if we have the susceptibility to have a flood in my city, for example, the civil
Yes.
defense can visit people's house and show them how the water is going to affect if they stay there. So it's a more visualizable thing to show to the people and to realize what is the real risk are. If you see the water level in your freezer, for example, in your
Yes.
room, so you're gonna see how is that going to affect you.
Perfect. Thank you, Gustavo. And can you stop your share screen, please? Okay.
Okay.
Thank you. Now we pass to the second presentation that is in presence, and is Blanchi Alisa, is right? Is okay, Alicia? And the title is Studying Urban Space from Textual Data toward a methodological protocol to extract geographic knowledge from real estate ads. Just 1 minute.
Thank you. Good afternoon, everyone. So in this presentation, I will show you a methodological protocol to extract geographic knowledge from real estate ads to carry a study on urban space. In this case study, we use real estate ads from the housing market of the French Riviera, especially the ads located at the coastal strip between the Italian border and Estival Mountains. So before beginning, let me introduce myself. I'm Alicia Blanqui. I'm PhD student in geography at Espace Laboratory located in Nice, France. I'm supervised by Giovanni Fusco and Karine Mselem. I work on social representation of urban space, especially the metropolitan area of the French Riviera. The technical protocol presented in this paper was constructed with Lucy Cadorel. She's PhD student in AI from INRIA in Sofia Antipolis. We both financed by Castilab's company, and we use real estate ads as a data source. And this direction, we decided to share our knowledge in computer science and geography. So to recontextualize my presentation, I studied social representation of urban space, but I want to change my approach because in recent years, some new data are booming since the emergence of social networks, online platforms that offer the possibility to collect massive digital corpora. In this direction, we decided to use real estate ads as descriptor to understand the social dimension of urban space. But the retrieval and treatment of geographic information from the text of real estate ads have many challenges. The main challenges are in the recognition, extraction, classification, and analysis of geographic information from text. All these challenges will be detailed in this presentation as follows. First of all, I will begin by a quick introduction of real estate ads, and then I will show you what kind of geographic information can be found and targeted in real estate ads. In the next part of the presentation, I will show you a protocol to extract geographic content, linking information extraction, relationship extraction, and information modeling. And to finish, I will show you first result on urban space of French Riviera to illustrate the protocol. So the real estate ads are massive punctual data located in space and contain descriptive text partly focused on urban space. Real estate ads are a source of information for a bound geographer. They are short text presenting properties inscribed in urban space and are intended for a target population. They speak indirectly about individuals, social groups, places, urban forms, and objects in space as they are represented by its author who are trying to talk the symbolic language of the targeted reader. But what kind of geographic information can be found in these real estate ads, and what are the consequences on the understanding of urban space? Firstly, as any descriptive text for a generic public, the author of real estate ads use common geographic entity to talk about place. For example, in this ad, neighborhood, city center, city. They are all common terms well understood by people beyond any formal definition by geographer or planner. It's also through the combination of natural or man-made amenities, linear, punctual, or surface-like features that the place characteristic can be evoked to the reader. In the real estate ads, the other fundamental category of geographic object is toponym or place name. These different geographic terms are differently evocative of social representation of urban space. For example, the combined occurrences between a geographic entity and toponym indicate what toponym means. In this ad, toponym CME is considered as neighborhood, but in other ads, CME can be a district, can be a boulevard, can be a museum. The second example shows the weakness of the place name because the place is just characterized as a specific features and it appears nameless. So in the case of city center, you don't know which city center. And the third example shows the strength of the place name. It's very evocative, but we don't exactly know what geographic feature is meant by the name. In this ad, you don't know what is Masséna. Masséna is a place, Masséna is neighborhood, we don't know. Besides, when advertisers talk about place, they also use specific characteristics of place that give a context to the proposed property. For example, famous district, dynamic sector, in our case, quiet neighborhood. This attribute associated to the place indicates social representation of place, but the absence of any specific attribute could be indicative of shared negative representation. Secondly, when advertisers talk about place, they also use specific and relatively simple concept of spatial relationship. Connection, proximity, concentration, inclusion. In the real estate ads, we are forming type of spatial relationship. The spatial relationship of situation is the location of the property within a given space and a given scale. The spatial relationship of proximity expressed by a temporal or metric distance or by qualitative relationship. The spatial relationship of visibility that involves sight instead of movement, and the notion of accessibility. The spatial relationship plays a central role in the understanding of spatial context or spatiality of geographic information in the text, because the fact that the property is located in the neighborhood of Cimier or the fact that the property is close to the neighborhood have different meaning in terms of placemaking. Thirdly, when advertisers talk about place, they also emphasize the presence of travel modes to indicate the spatiality of geographic object. The travel modes in the real estate ads relate indirectly to lifestyle and the constraints to household agenda. For example, the fact that the property is 10 minutes by car from motorway exit is not just important for the quantification of the time distance, but for the understanding of car mobility to access a metropolitan space. So we have seen four main types of geographic information from text. So how to study this information? So the real challenge here is the creation of protocol to deal with the social spatial phenomena and geospatial information in the text. So in this way, we decided to implement a particular protocol based on natural language processing techniques, NLP, to detect and extract geographic information from real estate ads. So in two steps, information extraction task and relationship extraction task. But this protocol can only be realized with an unsighted conceptualization of the knowledge present in the text and the phenomena to be described. The first task of our protocol is the information extraction by the name entity recognition method. This method helps to extract valuable elements from text automatically by the identification of entities to the classification into different categories. The real challenge here is to be able to extract all the geographic information automatically in the rich corpora of real estate ads. So, the first step of this task is focused on the identification and creation of classes of information to extract. So we decided to extract all the geographic information as detailed previously: toponym, geographic entity, travel mode, and the words used to create spatial relationship called space-time entity. The space-time entity is a little word at the center of spatial relationship, such as minutes, near, close. Second step is the creation of simple database of real estate ads annotated according to the previously defined classes. So in this research, we have annotated more than 1,000 ads from the corpus of real estate ads. The third step is the training and application of a learning model. So all the results, performance, and specificity have been detailed in the previous paper. You have the reference here if you are interested. So at the end of information extraction tasks, we obtain real estate ads annotated automatically by the model and according to the definite classes. But at this step, this geographic information extract have no link and are devoid of context. So in order to reconstruct context and relationship between the geographic information extract, we need to go through syntactic analysis. The second task of our protocol is relationship extraction. The objective here is to extract and reconstruct from the grammatical dependency all the link between the geographic object and their social spatial properties. So we select dependency parsing method using Stanza library, created by Stanford NLP group and suited for French language. So this library allows the grammatical structure between the words in the text by creating a tree of words, as you can see on this picture, according to the syntactic dependency between the words in the text. The dependency tree helps to understand the grammatical relationship between the geographic information, as you can see in color on this picture. So the careful analysis of grammatical dependency by focusing on the lexical link between the words made it possible to form a type of relationship to extract. So we decided to extract the association relationship between a geographic entity and toponym to reconstruct the geographical object. We decided to extract the spatial relationship between the space-time entity and geographic object to reconstruct the spatial relationship between the property and place. We decided to extract the modal relationship to add some information about the spatial relationship between the geographic information. And we decided to extract the attribute relationship to extract characteristic of place. So the extraction of this relationship are based on rule-based approach according to the recurring notified structure expressed by the grammatical relationship. So this step makes it possible to link all the pieces of geographic information together and give them meaning and context. So to conclude on this protocol, the extract information and relationship can be modeled in the form of grammatical dependency graph, where the nodes are the geographic information extract and the heart are the grammatical relationship extract also previously. So in this graph, you can see first the subject apartment have a spatial relationship with the space-time entity heart. The space-time entity heart have a spatial relationship with the geographic entity neighborhood. Secondly, you can see on this graph that the geographic entity neighborhood have an association relationship with toponym simier and have an attribute relationship with a characteristic quiet. So now we can understand by the graph that the apartment is located in Simier. Simier is neighborhood, and Simier is quiet. But several modeling choices have been added to this graph to produce common graph structure for all ads. So the challenge here is the transformation of listed ads into analyzable data by the structuration of information extract. So we decided to include empty nodes to indicate the absence of some key pieces of information. We decided to link all information related to the geographic object to stop name. We decided to link the property directly to stop name and model as parameter of the link all the information relating to the spatial relationship. So now we're going to see first application. So just first spatial visualization of the result of protocol. So whenever listed ads are transformed, as you can see previously, and contain precise location, they become punctual data and gives the opportunity to carry different spatial analysis. So in this presentation, we'll limit ourselves to different categorical representation of geographic information extract just to illustrate our protocol. So in this first map, you can see the spatialization of listed ads that talk about Promenade des Anglais in the city of Nice. This place is one of the most placements shown in the listed ad. Some ads locate the property by the proximity to this place, as you can see in green and yellow, and some ads locate the property by the notion of visibility. Probably these ads locate on the hills of Nice or front of sea. This place have an area of influence beyond the perimeter of ads located on it, as you can see in black, the ads located on it. In this second map, you can see the spatialization of listed ads that talk about the toponym Montferry in the city of Cagliari. So we would like to know what are the characteristics of Montferry. So in this ad, for more than half of ads, the toponym are considered as residential, as you can see in red. The residential area are generally considered neighborhoods in France, and Montferry is not an exception, but in this ad, Montferry can be considered as a neighborhood or district according to the geographic entity associated to stop name. So beyond this cartographic representation, we can conduct quantitative spatial analysis on this punctual data. So it will be very interesting to work around the question of the toponymy by the dominant and most used toponyms in space, intensity of use of toponyms, space that have an hesitant toponymy. We can study the reputation of place by the characteristic associated to the place, dominant attributes, multiplicity or not of attributes, absence of some attributes also. We can study also the factor of location by the geographic object located in space, what type of geographic object, multiplicity or not the factor of location. So the spatial distribution of this punctual data or the spatial distribution of this information can be measured by applying methods around the spatial density and by using methods around the fuzzy logic to model current support space for a given information. So it's perspective for my future research, so I can go into the details. So to conclude on this protocol, on this presentation, this protocol opens the way of spatial quantitative analysis of one of the most qualitative aspects of urban research, the social representation of place, but can be replicated and adapted for other issues, other language, or other space. So thank you for your attention and have a nice conferences.
Thanks, Alicia, for your interesting presentation. Are there any questions for the presentation of Alicia? No? Question? For me, it's just curiosity. For the training of the model of machine learning, you, I think, I imagine you use a big quantity of data, yes, or no?
In this project, I'm using 1,000 because it's very serious method to work by words of hat by hat. So we just have this 1,000 from topic.
Okay.
Models, but if you want to bigger model, we should have a big one.
Okay, and I don't know. I think yes, you have just evaluated the uncertainty of the model. Or I don't know if you know which could be the the uncertainty.
This process is AI. We have a model that the result of 18 or 90% of the results. So it's good for visit app because the visit app structured text with a lot of mistakes.
Yep. Good. Good luck for your future research. And Maralado? Maralado, are you present in this session? Yes?
Yes,
Okay.
I'm here. Hello. Good evening.
Just 1 minute?
Yes. I'm now.
Yes, because Letizia Bollini and Chiara Facchini. No, it's cancelled. Okay.
Okay.
So now we have the presentation of Maralado with
Yes.
other authors, and the title is present in the of this presentation is Smart City Industry 4.0: New Opportunities for Mobility Innovation.
Yes. Okay. Can you hear me and see my presentation? Can you hear me?
Yes.
Okay, thank you. Okay, so I'm Maralado. I'm a postdoc from the University of Cagliari, and I present the contribution written by Balletto, Borruso, Milesi, Tagliapietra, and Carboni. The title is Smart City and Industry 4.0: New Opportunity for Mobility Innovation. So the new phase of the manufacturing industry, called Industry 4.0, represents an epochal change. Among the production sector, the auto and automotive sector is a sector that sees the increasing market and electrification of its products, characterized in parallel by a percentage of modification of materials and products methods. The development of smart cities is closely connected with the phenomenon of Industry 4.0, which produces tangible effect in the urban spatial distribution of goods and services. The goal of our paper is to investigate the effect of Industry 4.0 on slow and ecological mobility and on specific environments, for example, historical and cultural areas, rural territory, protected areas. And the case study in this, according to this objective, is two protected areas. So they are the Molentargius Regional Natural Park and the Nora Archaeological Park in the Metropolitan City of Cagliari in Sardinia. that represents significant cases of a contamination lab that we developed between Luna Rossa team, the association Athena, and our department at the University of Cagliari. So before to introduce our case study, we should say that sustainable mobility offers great opportunities for territorial enhancement. Electric mobility improves accessibility and sustainable use of places to the entire population, not only in urban areas, but also in protected natural and cultural places, where accessibility is often denied or severely limited. The growing innovation in this research field introduces new content in urban mobility planning and in the design of roads and waterways, which become a fundamental component of more comprehensive urban regeneration policies and projects. Here, not only energy supply system, but also the entire organizational and functional structures of the spatial context should be planning, especially when this is not yet equipped services due to scarce use. For example, when we consider the ancient core of the city and its consolidated part, it is expected that the existing road network will constitute the main network infrastructure on which to organize the electric charging points and the related services. In context not yet equipped. The introduction of electric cars, micromobility, and electric public transport make it possible to promote the sustainable use of the ancient core, which is essential for an integrated conservation of cultural heritage. When we consider the rural context, the existing road will constitute the network infrastructure for electric cars, electric farm machinery, and micromobility, which is strongly related to slow tourism. Finally, electric vehicles and boats may represent an extraordinary opportunity to rethink the entire system of accessibility and use of protected natural areas, both territorial and marine, characterized by different degree of conservation. The need to ensure an effective and efficient energy supply system required the selection of the most suitable areas for creating charging stations for electric vehicles, both interchange nodes, refreshment points. Before to introduce our case study, we should say that the strategic plan of the city and the sustainable urban mobility plan represent the main form of government of the Metropolitan City of Cagliari. On the occasion of the drafting of the strategic plan of the Metropolitan City of Cagliari, innovative mobility proposals were collected, which are also capable of enhancing protected environment and cultural areas. One of the best proposals was the GoGo project, an electric boat suitable for navigation, developed by the engineer Talia Pietra as part of the stay in Cagliari of the American SCAP Luna Rossa. The GoGo is an electric boat, a trimaran of 3.85 in length, and having the ability to carry from 4 to 6 passengers, depending on the variance of the ability to recharge the batteries through photovoltaic panels that also perform the dual function of protecting the passengers themselves from solar radiation. The GoGo is built in thermoplastic materials, entirely recycled, allowing energy saving and raw material cost during construction. The GoGo allow access to protected marine areas, maximum environmental and water archaeological protection. For example, the GoGo guarantee the absence of environmental pollution, no wave motion formation, no use of fuel and consequent emissions into the atmosphere and water. So our objective is to try to image how can change the introduction of the GoGo, the use of land and water in Cagliari, in the Metropolitan City of Cagliari. In the first case study, the Molentargius Natural Park, we defined a combined framework between the stress level of cycling and sharing e-boat proposed in the city, which connect the Molentargius Natural Park, point 1, and the train station, point 5. The other point in the middle of the planned route of the GoGo, from 2 to 4, refers to the possible new hubs, which should include piers equipped with the necessary infrastructure, shading and refreshment point. The same analysis was developed for the Nora Archaeological Park. Also in this case, the combined framework between the stress level of cycling and sharing both proposed in the Metropolitan City of Cagliari connected the Nora Archaeological site with the nearby aquarium. The point 1 and 2 refers to the possible starting and ending point of the planning route of the GoGo. So, to say our conclusion, innovation in mobility are key factor for fostering the ecological and energy transition. What is examined here deals with two aspects tightly connected, the network side and the mean side. In the Metropolitan City of Cagliari, there is a need to keep moving the traffic share toward more sustainable transport means. Our attention was on new solution for water mobility. The GoGo boat can be considered an interesting example of such an application of this concept. A similar attention must be, however, put also on the network itself, with the presence of charging stations along the routes and possibility with the creation of low carbon emission energy production systems to supply them. Integrating a combination of a traditional charging point and the implementation of micro-grading systems could highly benefit a modal shift and a more sustainable mobility. Thank you for your attention.
Thank you, Mara, for your interesting presentation. And okay, thank you for the presentation that I found very interesting because you talk about little different topic in this session was very good. I don't know if there's question for Mara for this presentation. And for now.
Thank you.
So, thank you for participating to this session. Thank you for the presenter for the interesting presentation, and see you in the next session. Thank you, Mara.
Thank you. Thank you, everybody.
Bye bye.
Bye bye.